Hello again, welcome to another lesson in Algebra 1. Today we are covering section 9.2, part A, so we're splitting this over 2 days. Okay, and today we're going to cover multiplying polynomials, but not everything about multiplying polynomials. All right, so your warm-up was to rewrite the terms of each polynomial so that they are in the correct order. So right now we have a 4-term polynomial. This has degree 2 for this term. Second term has degree 3. The third one has a degree 1, and the last one has degree 0. So we need to reorder it in decreasing degree order. So 4x cubed is going to move to the front. 2x squared would be next, and then 5x, and then 4. So that's 4 terms. It's degree 3 polynomial, because the first term is degree 3, and the leading coefficient is 4. All right, number 2. This is degree 2. This term is degree 2. And this last term is degree 3. So our degree 3 term will go first, 3y cubed. And then we have 2 that are tied with degree 2. So we have to put them in alphabetical order. And xx will come before xy. So we're going to put 6x squared first, and then 2xy. All right, so this is a trinomial because it has 3 terms. Its degree, this was 3x cubed, is 3. Or 3y cubed, and the leading coefficient is 3. All right. Number 3, go through this one. The first term has degree 2. The second term has degree 2. Third term has degree 2, and the fourth term has degree 4. So obviously the degree 4 should go first. And then we have a whole bunch tied with 2. So m comes before n in the alphabet. So 6mm, or 6m squared, would be first. And then we do mn, so 8mn. And lastly would be 4n squared. So this polynomial has 4 terms. Its degree is 4, and its leading coefficient is 8. All right, our last one. The first term has degree 1. Second term has degree 0. Third term has degree 2. So we'll put the degree 2 first. Then degree 1, then degree 0. And this is a trinomial because it's a 3-term polynomial. It has degree 2, the largest of all these, and it has a leading coefficient of 8. All right, so for down below here, we're asked to list all of these things about each one of those. So if we go back up and look at number 1, once again, it has 4 terms. Each of those ones circled here, 1, 2, 3, 4. The degree is 3. That's the largest degree on any term. And the leading coefficient was 4, number in the front. Okay. For number 2, we have 3 terms. The degree is also 3. And the leading coefficient is also 3. Not 3 right there. In number 3, there are 4 terms. The degree is 4, and the leading coefficient was 8. And in our last one, we have 3 terms. The degree was 2, and the leading coefficient was once again 8. Okay. All right, on the bottom here, is the algebraic expression negative 2xy cubed minus 5x to the y power z plus 7 a polynomial or not? And this would be no. The second term has a non-whole number exponent. Okay. In this case, the exponent on the x is a y, and that's not allowed. No variables for exponents. All right, so this concludes our first page. Let's flip it over and see what's going on the second page. So our second page, we have multiply a monomial, that's the thing in front here, and a polynomial, algebraically and using the box method. So we learned about this in class last time. So we take the 2x, and we're going to distribute that to all 3 terms. This is the algebraic way. So 2x times 3x squared will make 6x cubed. 2x times 3x will make 6x squared. And 2x times 5 will make 10x. Okay. So that's the algebraic way, just distribute as normal. the box method, our first term over here is a 2x, and then we have three terms up here. So 3x squared, 3x, and 5. And these are all positive in this case, okay? So I take 2x times 3x squared. This gives me 6x cubed. 2x times 3x gives me 6x squared. And 2x from 5 makes 10x. And that's why when we rewrite it with the inside of the box, we get the same thing. 6x cubed plus 6x squared plus 10x. All right, so for number 2, I'm going to do the box part first. Then we'll do the algebraic way. So I have negative 2y. And inside my box, I have 3x squared y. Sorry, not inside, on top of my box here. We have our first term, 3x squared y. And then we have minus 3xy. We have plus 5y, and we have minus 3. Okay? So we do negative 2y times 3x squared y. That's negative 6 x squared y squared. Then negative 2y times negative 3xy, that gives me positive 6 xy squared. And then negative 2y times positive 5y gives me negative 10y squared. And negative 2y times negative 3 gives me 6y. Okay? So when I'm done here, I have negative 6x squared y squared plus 6xy squared minus 10y squared plus 6y. Okay? All right. Algebraically, same thing. We just take this negative 2y, the monomial on the outside, and we multiply it to all of the insides. And we've already done that. So negative 2 times 3 makes negative 6. Then we have x squared, and y times y makes y squared. Negative 2 times negative 3 makes positive 6. And then x and y times y is y squared. Negative 2 times 5 makes negative 10. And y times y makes y squared. And negative 2 times 3 makes positive 6. And we just have a single y left over. All right. You should be able to do both methods on the quiz next time. All right, number 3. 3n times 8n squared minus 2n. So 3n here. Up here we have 8n squared minus 2n. Let's figure out our box. So 3n times 8n squared. 3 times 8 is 24. And then n times n squared is n cubed. 3n times negative 2n. So 3 times negative 2 makes negative 6. N times n is n squared. So our final answer is 24n cubed minus 6n squared. Okay. Same thing could be done algebraically. I take the 3n and I times it to both of these. So 3n times 8n squared makes 3 times 8 for 24. N times n squared is n cubed. And then 3n times negative 2n, so 3 times negative 2 is negative 6. And n times n is n squared. All right, either way works, okay? And you should be familiar with both. All right, multiplying binomials. You must distribute each term of the first binomial to both terms in the second binomial. You then collect the like terms. So here's an example algebraically. What I do is I have two binomials. So I take the first term in the first binomial, 2x, and I distribute it to the whole second binomial, 4x plus 1. And then I take the second term, plus 3, and I distribute it to the whole binomial with 4x plus 1 again. So here I do 2x times 4x for 8x squared, 2x times 1 for 2x, and then back here I do 3 times 4x for 12x, and 3 times 1 for positive 3. And then we collect our like terms. The 2 in the middle are the same, so 2x plus 12x makes 14x, and then the 8x squared and the 3 come down. Now box method, we do 2x plus 3 on the top and 4x plus 1 on the side, although you could flip those, it wouldn't make a difference. Then we do 4x times 2x, which is 8x squared, 4x times 3, which is 12x, 1 times 2x, which is 2x, and 1 times 3, which is 3. And you can see the diagonals are like terms, so here we would get 8x squared plus 14x, and then we bring down the 3. Okay, 2x plus 12x will make 14x there. All right, let's flip it over and practice this a little bit. Okay, on our last page, we're asked to multiply each pair of binomials both algebraically and using the box method. So we'll do the box method first, and then we'll do algebraic second. Okay, so for the box method, we're multiplying 2x plus 1 and 3x plus 6. Doesn't matter whether you write the 2x plus 1 on the side or on the top of the box. It doesn't make a difference. In the end, you're going to get the same answer. All right, so first we'll do 3x times 2x, which makes 6x squared. And then we'll do 3x times 1, which will make 3x. And then we'll do 6 times 2x, which will make 12x. And then we'll do 6 times 1, which is 6. Okay, so our final answer here is going to be 6x squared. The two green ones are like terms, so we can combine those to make 15x. And then we bring down the positive 6. All right, so that's the box method. Okay. Algebraically, remember we're supposed to take each term in the first polynomial and distribute it to all the terms in the second polynomial. So 2x needs to be distributed to 3x plus 6, and positive 1 needs to be distributed to 3x plus 6. And then we'll combine our like terms. So when I distribute the 2x to the 3x plus 6, I'm going to get 6x squared plus 12x. And when I distribute the 1 to the 3x plus 6, I get 3x and plus 6. So the 6x squared comes down. The 12x and the 3x are like terms, just like they were in the box method, so they make 15x. And then the 6 comes down. And you can see a lot of similarities between the two methods. Okay. Number 7. Here's our box. We're doing 2 by 2 because it's a binomial times another binomial. So 6x minus 1, 2x plus 5. Okay. First one is 12x squared. That's 2x times 6x. And then we get 2x times minus 1, which is minus 2x. And then 5 times 6x, which is 30x. And lastly, 5 times minus 1 for minus 5. Okay. So when I combine all this together, just like before, the two green ones in the corners are the same here. So we get 12x squared, add up our like terms, will make 28x, and then minus 5. Okay. All right, up here, algebraically, we're going to distribute each term in our first binomial to the second binomial. So 6x needs to be distributed to 2x plus 5. And minus 1 needs to be distributed to 2x plus 5. So 6x times 2x will make 12x squared. 6x times 5 will make 30x. Negative 1 times 2x will make negative 2x. Negative 1 times 5 will make negative 5. And you can see, just like before, the two middle terms there, the 30x and minus 2x are like terms, so they will combine to 28x. Okay. All right, so there is a shortcut method to doing the multiplying binomials. It's an acronym called FOIL. It stands for first, outer, inner, and last. It helps us remember how to do the distributive property with binomials. It's really fast. When you get really good at it, it's great because it helps us when we go in reverse later on. So this is what we mean by FOIL. So FOIL stands for the first terms in each one. So the first term over this binomial is 2x, and the first term in the second binomial is 4x. 2x times 4x will make 8x squared. Okay. And then we do outer. That's what the O stands for. So the outside terms are 2x and 1 because they're as far away from each other as you can get. So 2x times 1 makes 2x. And then we have inner. The inside ones are 3 and 4x. Okay. Outside ones, and then the insides are the two in between them. Okay, 3 times 4x makes 12x. So we have almost got FOIL. We got FOI now. So our last are 3 and 1. Multiply them together, and you get positive 3. But you still need to combine your like terms here. So 8x squared plus 14x plus 3. Okay, and as you practice this and get really good at it, we ignore the top two methods for binomials. This is the fast, easy way to do it. Okay. All right, so let's do a couple, see if we can get good at it. Okay. All right, so here we're going to do FOIL. So first, outer, inner, and last. So first is going to be 5m times 3m, that makes 15m squared. Outer is 5m and 4, so that makes 20m. Inside is 2 and 3m, this makes 6m. And last is 2 and 4, so this makes 8. Combine your two middle terms, because they're like terms. So we get 15m squared plus 26m plus 8. All right, number 9. Our first terms are 3y and 4y, so that makes 12y squared. Outside is 3y and negative 2, so that makes negative 6y. Inside is negative 2 and 4y, so that makes negative 8y. And then last is negative 2 and negative 2, and they multiply to 4. So we get 12y squared minus 14y plus 4. Okay. All right, number 10, 2x times x. This is my first terms. This is going to give me 2x squared. 2x times 3, those are my outsides. So this will give me 6x. Inside, negative 1 times x will give me negative x. And last is negative 1 times 3. This will give me negative 3. So combine our inside and outside together. So 2x squared plus 5x minus 3. Okay. And in our last one, first terms are 4x and 3x. So that's 12x squared. Outside is 4x and negative 4, so that's negative 16x. Inside is positive 1 and 3x, so that's positive 3x. And last is 1 and negative 4 for negative 4. Combine your like terms. 12x squared minus 13x minus 4. And like I said, we'll practice enough that you won't even need to do the middle part there. Okay, we just say first, outer, inner, last, and do it in our head really quick. Okay, all right, I'll see you in class for some more practice on this, and then we'll finish up the rest of section 2.